If we have a data set that will always be between 500 and 600, what we can do is we can code the data. We could subtract 500 from each of the data, so instead of 518 it becomes 18, instead of 520 it becomes 20, which makes it a lot easier to type it into the calculator and a lot easier to write down. The only issue is that if we run statistics on it, like finding the mean or finding the standard deviation, then we need to make sure that we undo what we did with the coding. And with the standard deviation, there's a little bit extra that we need to remember. So let's cover that today. If we have large data, we can code it to make the number simpler. We can do two things. We can divide each number by something, and we could take a number away from each number. All these numbers are over 100, so let's start by subtracting 100 from each. You can see the remaining numbers are all in the 4 times table, so we can divide them all by 4. We can then find the mean for the coded data, and we can undo all of the things we did to the data to find the mean for the raw data. So we divided by 4 last, so we're going to times by 4. We took away 100, so we're going to add 100. So for our original data, the mean is 127 to 3 significant figures. We can do the same with the standard deviation, but we need to be careful though. The standard deviation compares each piece of data to the mean, so it doesn't care where our data is, only the scale of the distance from the mean. We therefore only need to divide the standard deviation by 4 and not add the 100. Let's have a look at these questions. So it tells us to use the y equals x minus 500 over 10 to code the data. So we're going to take away 500 from, say, the first piece of data, the 506, and we're going to divide it by 10. That will give us 0.6. And we're just going to go through and do that with each of the data. We're asked to find the mean and the standard deviation of the coded data. So we're just going to find the mean by working out the sum of the x over n. And so the sum of the x, when you add them all together, is 13.2 divided by 7, because there's 7 pieces of data, which will be 1.89. To find the standard deviation, it's a little bit longer. We've got to find the sum of the x squareds. We've got to find n, which is 7, because there's 7 pieces of data. And we've got to find the sum of the x's by adding them all together. Then we can use our formula. Now remember, we're working out standard deviation here, so the formula will be the square root of it. And so we're going to substitute it all into the formula, and we'll get 1.08 to 3 significant figures. So we've worked out the coded mean and the coded standard deviation, but now we need to find the mean and standard deviation for the original data. Instead of having to go through all the process again of adding them and dividing by the amount of numbers, we just need to convert the coded mean back into the original data. Now we've got the formula there, y equals x minus 500 over 10, and we're just going to use that, but instead of y we're going to have the y bar, or the mean of y. Instead of x we're going to have x bar. So we're going to substitute in the y bar as 1.89 and the x bar as just x bar, because we don't know what it is yet. And we'll go times both sides by 10, add 500 to both sides, and we can see x bar, or the original mean, is 519 grams. You'd think we would do the same with the standard deviation, but again we need to remember with the standard deviation it doesn't care where the data is. If you add 100, take away 100, it doesn't affect the standard deviation at all. What affects it is if you multiply it or divide it. So the only thing we need to worry about is the divide by 10, and we can ignore the minus 500 at the top. So we're going to times 10 both sides, which will give us 10.8 grams for our original standard deviation. Let's finish on this. Coding used to be very useful in maths, but explain why it's not as useful now. If you know, write it in the comments below. And you can also come to onmaths.com or click the link in the description where you can access all of our free A-level papers and predictions, and you can even save your scores with a free account. This video is part of a larger A-level course that you can follow along with at onmaths.com.